Hello and welcome to this series of videos titled Lighting My Fair Lady, a comprehensive look at the process of lighting a show. My name is Matt Grenier and I've been doing lighting design for theatrical productions and dance on the community and school level for about 7 years. All of my technical theater and lighting design training has been through a mentor and via repeated practice, as well as just reading. I currently work as a part-time technical director for the Martin W. Capel Theater at the Shenango County Council of the Arts in Norwich, New York. I do freelance lighting design work for local schools and dance companies, and I'm also a minor of theater at Binghamton University. I originally wanted to develop this video as a walkthrough of the lighting for the Norwich High School Musical Club 2008 production of My Fair Lady. It's developed into more than that. It's developed into a series of videos that are going to provide you with a comprehensive look at the process of lighting a show. Don't worry, you don't have to know anything about My Fair Lady to follow these videos. You should just know that it's a theatrical musical and we're talking about theatrical lighting design. I'm assuming if you're watching this, you've been to a few theaters and you've seen some stage productions. This isn't intended for people who are very experienced in technical theater or stage lighting, because you're probably going to know most of the things I'm going to tell you. These videos will be conceptual, so if I do refer to technical details, I may not be doing so entirely accurately. For example, at one point I'm going to talk about how lighting is controlled via a signal called DMX512. I'm not an expert on this, and I don't claim to be, so I might not be entirely accurate when it comes to the technical details of how that signal works. But the concept will be there, and that's what's important. You'll learn the concept behind how lighting is controlled. I wasn't concerned with the length of the videos as I was creating the material. I realized that the combined length of all these videos is fairly significant. It's probably over 3 hours. If you're really interested in lighting design, I suggest that you watch all of them, because it has the potential to provide you with a starting point for further training. If you're a more casual observer, I suggest that you watch the videos one by one as you have time. Just note that the later videos will require that you have a basic familiarity or memory of the material in the previous videos. I haven't received any consultation in creating this series of videos. Most of the material in the videos was created by me, with the exception of some images gathered on the web and some formal information and a few illustrations from J. Michael Gillette's book called Designing with Light. So with that, let's talk about the goals of this video, or this series of videos. First, I'm hoping that I'll develop an appreciation for the work that takes place behind the scenes for pretty much any theatrical production. All the aspects of the production involve a lot of work. Second, this is the big one, this is the main purpose: learn about the process of lighting a show. That's what we're really going to talk about, the process of lighting a show. Third, foster interest in electrical and operational lighting work, as well as lighting design. So electrical is installing the lighting, operational is running the lighting, designing is designing the lighting. 4, provide a basis for training in lighting. So like I just said, if you watch this whole series of videos, you're going to have a pretty good starting point for actually learning more about lighting in whatever aspect you're interested in. And then finally, we're going to do all this by reviewing the steps taken to light the 2008 Norwich High School Musical Club production of My Fair Lady. So that's this production is just going to be basically a vehicle for talking about everything that we need to talk about. So let's look at the outline. Alright, the series of videos is broken into 5 sections. The first section is going to talk about what lighting design actually is. So this first section is not going to talk about that production of My Fair Lady at all. This is going to give you all the background information you need about what lighting design is. It'll talk about how we control light. It'll talk about all the different, not just how we control light, but all the controllable qualities of light. So the distribution of light, how we control the intensity, how we control movement, and how we control color. That's all going to be talked about in this section. And then we're also going to talk about how the design is documented. What paperwork do we need in order to go into a theater and actually put the lights where we need them to be. And then last, how are design decisions made? So basically, how do you go about learning how to design? So that's all Section 1. Section 2 is where we're going to start getting into My Fair Lady. We'll talk about how you analyze a script, and we'll also talk about how scenery can affect the lighting. In Section 3, this is where we'll talk about the process. What process is followed to get from the script to that design documentation? How do we actually go about that process? So we'll walk through that for My Fair Lady. 4, how is the design implemented? How do we actually take all that documentation, go into the theater, put the lights where they need to be? How do we focus them? How do we record the cues that make up the show? How do we play that back during the show? All that will be talked about and how we implement the design. And then 5, what is the final result? So we'll talk about what the final result of all of those things are, and we'll look at photos from the production of My Fair Lady and talk about how those different things were created using the design that we came up with. So let's get started. Okay, let's talk about lighting design. What is lighting design? Here's our definition. It's the creative use of illumination to enhance the audience's understanding and appreciation of the production by visually supporting the production concept. So what's important here? It's the creative use of illumination to enhance the audience's understanding. So it's a creative process, and it's all about enhancing the audience's experience of the production. And we do that by visually supporting the production concept. What's the production concept? It's the overall vision or direction or theme or purpose of the show, the overall concept of the show. So from the definition, we get 3 goals of the lighting designer. First, we want to selectively illuminate the stage. So that means we want to bring focus where we want the audience to focus, and we want to cause the audience to disregard things on stage that aren't important. Second, we want to model the actors, the scenery, and the costumes. So it's like drawing a picture. When you draw a picture, you draw what you want the observer to see. When you paint something, you paint it the way you want people to see it. So when we light something, we light it the way we want it to be seen. And third, support the production concept. So if we're doing Midsummer Night's Dream and it's set in the 1950s, or we're doing Romeo and Juliet in the style of Chinese opera, those are production concepts, and whatever the production concept is, the lighting has to support it. Okay, so we've got our definition of lighting design, and we've got 3 goals of the lighting designer. So next we go to functions of stage lighting. First function, visibility. So if you look at all these images here, the characters or the dancers or the people that need to be seen by the audience are visible. So that's visibility. Second, we want selective focus. So we want to selectively illuminate the action. So here in Little Shop of Horrors, we want the focus to be downstage center where Audrey and Seymour are talking. Here in My Fair Lady, we want the focus to be on Higgins and Eliza. And here in Charlie Brown, if you could see the whole stage, you'd see that the focus over the whole stage is right here on this group of characters at the end of this song. So that is selective focus. So third, modeling. And like we just said, modeling is creating the image that you want the audience to see. So in all of these photos here, these are the images that I wanted the audience to see. So modeling is achieved just by doing that. To be more specific, modeling involves background separation. So like here, we want to make sure that all these characters are separated from the background. They don't blend in, they stand out. Modeling also has to do with color blending. It also has to do with definition of line and shape. So in this dance image up here, we want to make sure that the audience can really see these lines and shapes that the dancers are trying to produce with their choreography. So that's modeling as well. Okay, so next is mood. Now, mood is affected by a lot of things. It isn't necessarily any one single thing. It can be affected by color. So like here in Little Shop of Horrors, we've got the colors going on in the backdrop. It can be affected by intensity, just the overall brightness of the scene. It can be affected by the direction that lights are coming from. It can also be affected by how quickly lights change, maybe from one state to the other. So it isn't any one single thing. And if you just look at all these photos here, you can get a sense of the different moods that are trying to be established or evoked by the lighting in each photo. So what do we just said? We just said that mood isn't affected by any one single thing. But what it turns out is the four things that mood is affected by are also the controllable qualities of light. So there are four things that we can control about light, and they all contribute to mood. When I was trying to figure out how to organize this it turned out that the best way to talk about lighting design in general is to go through what we can actually control about light. So here are the four things. First, we have distribution, and that's a general term that includes the direction that light comes from, the size and the shape of the light beam, the clarity of the light beam, so how soft or how sharp the beam is, and also the texture of the light. A second thing that we can control is intensity, and that's obvious, that's just the brightness of the light. Third thing is movement of the light, and there are three types of movement. The first one is a shift from one cue to the other. So if you're looking at the stage, the lights are all a certain way, and all of a sudden they just shift from that state to another. That's a form of movement. Second is light sources from offstage moving. So if you're sitting in the audience and you see light moving across the stage, but you can't see where it's coming from, that's what we're talking about here. And the third one is light sources on the stage moving. So you say that there's an actor holding a lamp in their hand or something as they move around. That is a light that you can see, and you can also see the source of the light. So that's that form of movement. And then the last thing we control is color. That's fairly obvious, it's the color of the light, but there are a lot of subtleties involved in mixing colors and light, and it's not necessarily intuitive, so we'll see what is involved in color mixing when we get to that. So those are the four controllable qualities. Let's go through them now and see how we actually control each one of these things. Okay, how do we control distribution? Well, number one, we can place lights in a variety of different positions. So put a light in a different position, obviously the light is going to be coming from a different direction, and it's also going to affect the size and the shape of the beam, because if it's further away from the stage, the light will be much bigger when it reaches the stage than if the light were closer to the stage. And also if the light is at a very low angle to the floor, it's going to elongate and it's going to spread out across the floor more than if it were, say, pointing straight down at the floor. So that's how putting lights in different positions will affect direction, size, and shape. Then we also have different types of lights, and different types of lights have different characteristics. They're just going to affect all of these things about distribution. Individual lights are also focused differently, so two lights can be in the same position but be pointed in different directions or be adjusted differently, and that'll affect distribution. Mentioned texture. We could create textures by, say, bouncing light off of something. We could bounce light off of like a pool of water, and then you would create texture that way. Or we can also pass the light through something, like something with holes in it, like a stencil, and it'll create a pattern that'll create texture. And that's we use a gobo to do that, and I'll explain what that is in a minute. So let's talk about what kinds of lighting positions are available to us. And we're only talking about a proscenium style theater. So proscenium is this big opening, audience is sitting down here and up here in the balcony, and this part of the stage in front of the proscenium is called an apron. So proscenium style theater may or may not have an apron, but this is the style of theater we're going to be talking about in terms of lighting positions and everything else, because Norwich High School is proscenium style. So My Fair Lady was done in proscenium, and most theaters are proscenium style theaters. Okay, so lighting positions available to us. First, we have over the stage. So we have a whole bunch of pipes over the stage. We can decide which pipe we want to put a light on, so that will give us depth control. We can decide where along that pipe we want to place lights, so that gives us control in terms of distance from the center of the stage. And then we can also decide how high those pipes are off the floor. So we've got all three spatial dimensions. We can put a light pretty much anywhere we want, as long as it doesn't interfere with scenery or curtains or something else. Our over the stage positions, generally every type of lighting direction we can achieve. We can do side lighting, we can do back lighting, we can do front lighting. So we can light from pretty much any direction from over the stage. Next position is front of house. So the audience is sitting right beneath these lights. And basically we've got a long pipe again. We can decide where the lights go along that pipe. This particular pipe here at Norwich High School is fixed. I can't control the height of it above the floor, but I do have another pipe up here where I can control, again, distance from center. I can place a light anywhere along it. And if I put lights down here, I can put lights down there, or I can put lights up here, and that gives me some height control. And this upper pipe is also closer to the stage than the lower pipe, so that's giving me depth control. So again, I'm getting all three spatial dimensions. And some theaters might have more options. They might have another pipe back here, another one back here, another one up here. So depending on the theater, there are different options and different obstacles. But in general, this position, this front of house position, is only for front lighting in general. All these lights are lighting the stage from the front. They're not over the stage, so we can't really backlight or side light from these positions. Okay, so next, a proscenium style theater might also have something called a box boom, so a vertical pipe mounted on the wall, and we can decide how high we want to place a light up that pipe. And some theaters might not have any box booms. Some might have multiple, so there might be another one back here, another one here, maybe another one closer to the stage. So that just gives us more front lighting possibilities. A theater might also have a balcony rail, so it might also have a pipe along this balcony edge where we could hang lights, and again, it would just be another front lighting position. Next, we have a couple special positions that are pretty flexible. We could put a light on a floor base, and we could put that floor base pretty much anywhere we want to use it. So that we can is just an option we have for doing special things. And then we also have this freestanding boom, which is generally used for side lighting, especially for dance. So I place lights on here, put one at each side of the stage, and then I'm side lighting the whole stage. These can could potentially be mobile. They could have wheels on them, and then we would call them rovers, and then they could be moved out of the way, maybe for a scenery change or something like that. They could be moved around as necessary. So this is generally used for side lighting, but both of these you can use for all sorts of different things. So those are all of our lighting positions available to us. We've got all three dimensions over the stage, all three dimensions out in front of the stage, and then additional positions like balcony rail, box boom, if the theater has it, and also positions like this. So lots of different positions available to us. Okay, next, types of lighting instruments. I'm going to go through this fairly quickly because I don't want to spend a lot of too much time on the details, but the ERS here is the most widely used light in all of theater. Basically, this is called an ellipsoidal reflector spotlight. There's a lamp back here surrounded by an ellipsoidal reflector, and it reflects that light, the light produced by the lamp, through two lenses, and it comes out at a particular angle. So say 36 degrees, and that's how I would tell someone what kind of ERS I needed. I would say I need a 36 degree ERS. So that basically determines, that's going to determine how big this light is when it hits the stage. Some other things about this light, it has these four tabs here. These are shutters, so I could take the beam of light and I could cut it like this. I could actually make cut the light into a square if I wanted to, so I can shape it around things. It also has an accessory slot, so I can put different accessories made just for this light inside it. So that's all of those things together are generally why it's one of the most widely used. I can also adjust the sharpness of the beam, so I can make that beam edge very sharp, or I can make it nice and soft. So pretty much I can focus it any way I want. These other types here, for now this just produces a soft circle of light. It's just a lamp behind a lens, and I can make that. I can make the size of that circle bigger or smaller by adjusting the distance from the lamp to the lens. And if I were telling someone what kind of Fresnel I needed, what size, I would tell them the diameter of the lens: 6 inches, 8 inches, 10 inches, 12 inches, whatever size I needed. The par is basically a flood lamp inside a can. So we often call this a par can. It's just a lamp inside a can. And the hot part, or the brightest part of the light beam, is actually shaped like this. And I can rotate the lamp inside this can. So basically the hottest part of the light, or the brightest part of the light, is kind of this long, narrow shape. So I might use it to I'm going to use it to light down narrow pathways. And another thing about both the Fresnel and the par, they're both soft lights. I can't sharpen the edge of the beam really. It's just a soft, it produces just a very soft edged area of light. Okay, next, strip light. This is just a bunch of flood lamps, and each, say every 3 is circuited together, and I would color them together: red, 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 and then when I turn on this circuit, I'm going to get all the red lights. When I turn on a different circuit, I'll get all the blue, all the green. I would get a different color, and I use that for lighting backdrops, for backlighting, for washes, for footlights, whatever. Just gives me several color options. Cyc light is used especially for backdrops, so each one of these sections of this are considered individual lights, and I would color each section differently. And then I would have another one of these and another one, and they would cover the whole width of the backdrop, and then I would turn on all the red ones, and it gives me just a nice big wash of the whole backdrop in whatever color I have in those lights. The last one here is an intelligent fixture. This is just an example. There are all kinds of intelligent fixtures. They're very sophisticated. It has an onboard computer, has an onboard dimmer. This is what we call a moving head, because the lamp is actually inside this head here, and this moves around. Some intelligent fixtures are what we call moving mirrors, so the light would just shine onto a mirror, and then the mirror would be moved around, and that's how we would control the light, rather than moving the whole lamp around. So this has an onboard computer, onboard dimmer, It has all kinds of different features. Maybe you can change the color, you can change, you can make it strobe, you can adjust all sorts of things about it. So they're very, very sophisticated. And one thing I didn't mention at the beginning here was that the scale of all these lights, this is not shown correctly. This is much bigger than this. So the scale here, the scale of these images, just disregard it. Each one of these are the sizes are not the way they're shown here. Also, a comment about the weight. These are generally very heavy. These are pretty heavy. And these are all kind of moderate. These are all, maybe 10 to 20 pounds. This might be 50 to 100 pounds. Same thing over here. So a reason why the weight is important, because if we're going to start hanging those from lighting positions, we need to know how much load we're putting on those different pipes that we're hanging them from. So those are different, most common types of theatrical lighting fixtures. Last thing, we talked about texture. What's a gobo? A gobo is just basically a piece of metal like this with a pattern cut out of it. And it's called a gobo because it means goes before optics. And it's called that because in this ERS, the optics are the lenses, and the gobo would go in that accessory slot before the lenses. It has to be before the lenses, that way we can use the lenses to focus and sharpen the image to create, to really be able to see that pattern that you're trying to project. So that's why it's called goes before optics. Here's an example. This is a breakup gobo, 78219, made by Roscoe, and this was a dance that I used it in. You can see the texture on all the dancers. Some of the texture is being created by the costumes themselves, but then you have the effect of this gobo over all of the dancers. Another thing about gobos is you can use them to create special effects. My brother designed this custom gobo for Little Shop of Horrors, so we send the company the pattern and they cut it out of steel and send it back to us, and then we can project it on a wall or do whatever we want with it. So we can use gobos for both texture and for special effects. Okay, we've talked about how we control distribution. Now, how do we control the intensity of the lights? Well, the lighting system is built to do this. Obviously, when a light is on, it's full intensity, 100%. When a light is off, that's zero intensity, 0%. So, how does this work? Well, we have a light hanging from a pipe, obviously. We already talked about that. We plug that light into an outlet, or a circuit. That circuit receives electricity from a dimmer that's located inside a dimmer rack, usually in a loft or a basement or some closet somewhere. And that dimmer controls how much electricity is being sent to that circuit. So dimmer is, I don't know very much about dimmer technology, but it's just basically controlling how bright the light is by controlling how much electricity goes to the light. One thing we can also do is I can connect multiple lights to a single circuit. So I could connect 2 or 3, that's called two-fering or three-fering, and then all the lights plugged in to circuit 1 are going to be turned on when dimmer 1 sends electricity to them. You have to be a little careful with two-fering and three-fering because you might exceed the capacity of the dimmer. But basically the point is dimmer 1 will send electricity to all the lights plugged into circuit 1, even if it's 2 or 3. Another important thing here is note that circuit 1 is getting electricity from dimmer 1, circuit 2 is getting electricity from dimmer 2, circuit 3 is getting electricity from dimmer 3. That's called a one-to-one configuration. We're just going to pretend like every single theater is one-to-one configuration. Some aren't, but most proscenium-style theaters are set up that way. So if I say circuit 1, it's the same thing as saying dimmer 1. So I'm just always going to use dimmer. If I say dimmer 2, it means circuit 2. They're both the same thing. Okay. Now, we know how electricity gets to the circuits, but what tells the dimmer how much electricity to send? Well, some kind of controller, basically. And the controllers we use are our lighting console or our architectural controls. Those are the buttons that you'll see right inside the theater door that we use to turn the lights on when the lighting console is turned off. Those are what we use to tell the dimmer how much electricity to send. Basically, we do that by these devices send a signal to a receiver in the rack, which just basically carries that signal onto the dimmers. Okay? This signal is called DMX512. It is a signal composed of 512 parts carried over this single wire. And those 512 parts, which we're going to call packets, those are individual parts of the signal. Each packet, each one of those 512 parts, contains an instruction about how much electricity the dimmer should send. So think of this as like a string of little packets like this going all the way to 512. This is number 1, this is 2, 3, 4, and it goes all the way back to 512. Packet 1 has an intensity value inside of it, say 75%. So it comes into this receiver, and that message of 75% is carried up to dimmer 1. Dimmer 1 passes 75% of its electricity or its power over to circuit 1, and the light goes up to 75% of its value. So packet 1 contains the intensity information for dimmer 1. Packet 2 contains intensity information for dimmer 2. Packet 3 for dimmer 3. Okay, so that's also 1 to 1. So if I say DMX packet 1, that's the same thing as saying dimmer 1 and the same thing as saying circuit 1, because they're all connected. So again, we're just going to use the word dimmer to refer to all three of those. That way we're all on the same page, we just use the same word. When I say dimmer, it means the same thing as DMX packet 1, or as if I say dimmer 1, it's the same thing as DMX packet 1 or circuit 1. Now, what's happening with this signal? This string of 512 packets is being sent over and over and over and over again many, many times a second. So by the time it gets through that whole string of 512 instructions, it's already starting over again. And because it's happening so fast, any change I make on the lighting console is reflected basically instantaneously. Because that signal, because these packets are repeating so quickly. Now, how many dimmers are in the dimmer rack? At Norwich High School, there are 96. Well, I said this signal has 512 parts. Well, we're only using the first 96 parts, the first 96 packets. All the rest of them we're not using because there aren't any dimmers above 96. Okay? So that's basically how this system works. Lighting console is sending a signal, a string of packets. Inside each packet is the intensity value for the corresponding dimmer, which then passes electricity to the circuit and thus turns on all the lights that are connected to that circuit. That's how the lighting system works. That's how we control intensity. Okay? So, what's next? Well, this is the actual lighting console that we have at Norwich High School. It can send 1,024 DMX packets. I just said there are only 512 packets in a signal. Well, that just means that it can send two separate signals. It can send two separate DMX signals. Okay? We only use one of them because we only need 96 packets. Okay? So, remember, DMX packet, this is the same thing as a dimmer. right? So this board, this lighting console, can control up to 1,024 dimmers. We only have 96 at Norwich High School, so we're not using all the rest of those. Now, we control those using channels. This console can have as many as 192 channels. Again, basically, what we're going to do is we're going to use a channel to control a dimmer. So we have to assign our dimmers to our channels. Okay? We'll get to cues in a minute. Let's look at the patch mode of this lighting board. This is how we assign dimmers to channels. Channel is just something, it's just a convention within the lighting console that we use to control dimmers. We need to have something within the lighting console that we use to control dimmers, and that's what channels are. Kind of like on a soundboard, there are different channels for different microphones. In this case, it's different channels for different dimmers. Except one thing we can do is we can assign multiple dimmers to one channel. On a soundboard, you wouldn't do that. You'd never want two microphones coming into the same channel, because then you couldn't control the two microphones separately. But in lighting, we may want to control two different dimmers together. Maybe there are two different lights that we want to control together. We would do that by assigning them both to the same channel. And again, note here, packet 11, same thing as dimmer 11. It's 1 to 1. Okay? So, one other note, I can put multiple dimmers on a single channel, but I can't put the same dimmer in two different places. It can only be on one channel. So, that way there's no conflicted messages trying to be sent. Okay. So that's the patch mode. We're deciding what channels are going to control what dimmers. Okay, so why are we doing this? That's the question. Why are we doing this? Why do we need channels? Say I want to control 5 lights. They're all located in different places. So each light has a different dimmer number. Okay, 5 lights, different locations, different dimmer numbers. If I want to control all 5 lights individually, then I have to assign each light to its own channel. If I want to control all 5 lights together, then I need to assign all 5 lights to the same channel. The problem is I need to know that I always want to control those lights together. I always want to control them together. If I always want to control them together, then I'll assign them all to the same channel. But if sometimes I want to control them separately, they need to be on their own channels. Okay? Alright, so I assign them to channels. Let's say we want them all to be individual. I would assign them all to their own channels, and then I would identify those channels by the purpose of the lights. So if one of those 5 lights, its purpose was to light me at a particular point on stage, then it would say like light format. It would be labeled like this, and each light would be its purpose would be written down like that. If I had multiple lights on the same channel like this, it's amber. So this is multiple amber lights all on the same channel right here. Okay. This brings up, how do I turn channels on and off? How do I control channels? Well, I set the channel intensity, I set the channel level using sliders or a keypad. So I can use these sliders, right, to turn channels on and off. But not every channel actually has a slider. There's 96 on this lighting console. We only have 96 dimmers, so at Norwich High School we do have sliders for every single channel. Some lighting consoles don't have these sliders for every channel though. You might be using hundreds of channels and you just don't have enough sliders for all of them. So you would then type in the channel number. I would use the keypad. I would say channel 5 at 75%. and then that would turn on the channel at 75%, rather than taking one of these things, one of these sliders, and putting it at 75%. So basically, I need channels to control dimmers. When I put a channel at a certain level, it's going to put all the dimmers assigned to it at that level, and that'll make the lights connected to that dimmer also be at that level. So I need channels to control dimmers, and I need them to do it more efficiently. So if I always need to control 5 together, I'm just pushing one button instead of selecting all 5 of them over and over and over again every time I need to select them together. Okay, so that's why we're doing this. Now, this is a summary of what we've just talked about. This is the hierarchy of lighting control. We've got the lights at the bottom. They're plugged into circuits. The circuits are getting electricity from dimmers. The dimmers know how much electricity to send because they're receiving intensity instructions inside DMX packets. And remember, these are all one-to-one. Circuit 1, dimmer 1, packet 1, they're all the same thing, so we just call them dimmers. And we know that we assign those dimmers to channels. So when we put a certain channel at 75%, we put the dimmer at 75%, and that puts the lights at 75%. Okay? So that's everything we've talked about so far. That's how it works. Now we're going to add this new thing to the top called a cue, and we'll get to that in a minute. But one thing, let's go back. One thing I want to mention before I go on to cues, what about intelligent lights? When you see a show on TV or a rock and roll concert or something like that, all those moving lights, all those intelligent fixtures, how are we controlling those? How are those controlled? Well, basically, we don't have to use DMX packets to send intensity instructions to dimmers. We can use DMX packets to send all kinds of instructions to intelligent fixtures. Okay? So an intelligent fixture might be receiving 20 DMX packets, and the first few packets might be telling it how to tilt, how to pan, what color, and then the subsequent packets are telling it what color should I be, how fast should I strobe, all the different features of that light. This light is listening to the instructions of a set of packets, so it knows what to do. And then I could daisy chain more intelligent fixtures together. So because this intelligent fixture has an onboard computer, I tell it which packets it should listen to. And basically, the packets that I'm sending to the dimmers are different from the ones I'm sending to the intelligent fixtures. And that's pretty easy. Norwich High School, we only have 96 dimmers, and the signal has 512 packets. That's at least 400 extra packets that we're not using. I can use those extra 400 packets if I configure the board properly, configure the lighting console properly. I can send those 400 packets to some intelligent lights, some intelligent fixtures, and control them that way. So that's how all those moving lights are controlled. Okay, so let's go back to this. What are cues? Okay. We'll get to cues in a second. This is the main display of our lighting console. This is what it looks like. So all these gray numbers here are the channel numbers, and these are my intensity values. You can see here I have a cue list, and this is the current cue that's being played back. So let me go forward here. Let's jump into this just for a second. How do we control movement? We use a computerized lighting console to record combinations of intensities and play them back smoothly with specified timings. That's what a cue is, a combination of intensities. So when I go back to this is cue 75, and all the intensities that you see here are recorded in that cue. So when I play back cue 75, I'm going to get this combination of intensities that you see on the screen. And cue 75 happens to have a time of 4 seconds. So when I play back cue 75, it's going to play back in 4 seconds. It'll take 4 seconds to fade to the intensities that you see up here on the screen. So that's what a cue is. It's a combination of intensities that we've recorded. So here's a cue spreadsheet. So what you see on here are, again, the gray numbers are our channels, and all these colored numbers are the channel intensities. So this is Q1, Q2, Q3, and you can see how we're achieving movement here, because as we go through this cue list, channels are changing from one value to another, and that's how we're creating movement. What do these different colors mean? Well, green means the channel is decreasing in value. Blue means the channel is increasing in value. Purple means the channel is staying the same. When a channel stays the same from one cue to the other, that's called tracking. It's tracking from one cue to the other. So basically, this is how we run a show. We record these cues, these combinations of intensities, and then we play them back in this order. Okay, so that's how the show is actually run. All we have to do is say play back Q1, and we just push a go button, and we can go through this list, and that's how it's done. Okay, so let's go back to how we control movement. We've already talked about this one. I know that was pretty complicated, probably, but I wanted you to really understand how we actually control lights. It's one of the things that people probably wonder about the most. How do we actually control all the lights we're using? And that's how it's done. It involves controlling both intensity and it involves movement, because we record our combinations of intensities. So we're controlling intensity, and then we play them back. And that's how we achieve movement from one cue to another. Okay, so now what are some other ways we control movement? Well, follow spots, intelligent light fixtures. We already talked about intelligent lights. Obviously, they can move. If you've ever seen a rock and roll concert, there are lots of moving lights, lots of intelligent lights, and they're moving and doing all kinds of things. Follow spots we'll talk about in a minute. You can build light sources into moving scenery. Good example of this, I just did a production of Romeo and Juliet, and at the end of the show we had these lit Chinese lanterns come flying in over the stage. So not only did we have these lit lanterns, but they were moving into the picture. So that's one way to create movement. You could use flickering flames as light sources, so you get a candle flickering or something like that. And you can also equip actors with light sources that will move with them around the stage. So a candle, if they're walking around with it, a lantern, a flashlight, something like that, will also create movement. So the only one that we're going to talk about now, since we've already talked about a couple of the others, are follow spots. And we're going to talk about this because follow spots are traditionally used in musical numbers, and My Fair Lady has a lot of musical numbers. So what's a follow spot? It's used to follow performers around the stage, and it requires an operator. So it's a light just like this. Big housing usually on a rolling, some kind of tripod base, and the operator will just stand behind it and point it where it needs to be pointed, adjust what needs to be adjusted. It achieves selective focus, so it draws the audience's attention to a particular character, and it does that by moving, by following them around, and through high relative intensity, so it's brighter than most of the other lights on stage. It includes an iris, so you can make the light smaller or bigger, a shutter, color boomerang, so you can change the colors, you can make it soft or sharp, and it has a dowser, so you can close it and shut it off and turn it back on. So that's the basics of follow spots, and we'll look at a follow spot cue sheet once we get to that point in My Fair Lady. Okay, we've talked about how we control distribution, intensity, and movement so far. The only thing left on our controllable qualities of light is color. So how do we control color? Well, first way is we can put a gel or a filter in front of the light, and that will subtractively color the lights. We'll talk about that in detail in a minute. We can also take lights of different colors, blend them together, and additively create new colors. So we've got subtractive and additive mixing. Then we can, and then when we have lights in different positions, colored differently. Basically, that will affect the color because the relative direction of two lights will determine how much those colors mix together. So we'll see what that really means in a minute also. Last two things on here, the intensity of lights can affect color. A tungsten filament lamp, when it's dimmed pretty low, the color temperature of the lamp will drift, and it's called amber drift. If there's no color in the light at all, the light will go from being basically white to amber. And also different types of lamps will affect color because the different types of lamps have different color temperatures. The tungsten filament lamp drifts to amber because its color temperature changes when it's dimmed. So if you want to learn more about that, look up what the definition of color temperature is, and you can kind of get an idea what that really means. Okay, let's look at the color wheel for light. The primary colors in light, unlike pigment, are red, blue, and green. Why are the primary colors red, blue, and green? Well, it has to do with how our eyes actually detect light. Our eyes only detect red, green, and blue light, and our brain is actually what interprets the mixture of red, blue, and green and mixes those three colors into other colors. So all the time we're only seeing red, blue, and green, but our brain is determining how much red, blue, and green. It's taking that information and it's creating the other colors basically. So that's why red, blue, and green are our primary colors. Okay, what are some of the definitions we have here? A hue is what differentiates one color from another. So hue is what differentiates blue from red and red from green, green from blue. A primary hue is not derived from any others, so that's our red, blue, and green. A secondary hue is the result of mixing two primaries. So cyan is the result of mixing blue and green, magenta, red and blue, yellow, red and green. And complementary are two hues that mix to yield white. So if they're opposite each other, yellow and blue, they'll mix to yield white. Saturation is the percentage of a hue in a mixture. So if I have a mixture of many different colors, the saturation is how much of each color is in that mixture. Okay. Another thing is I can actually create red by mixing yellow and magenta. Or I can create blue by mixing cyan and magenta. So that's called CMY, cyan, magenta, yellow, color mixing. And a lot of intelligent fixtures will mix color that way with a CMY color mixing system. So you can actually mix all the colors either way, red, blue, and green, or CMY, RGB or CMY. Okay. Next, all right. The first thing we talked about was gels or filters and subtractive color mixing. So basically what we do is we have a light, full spectrum light source, so it's white, and then we put a red filter in front of it, and it filters out every single color except the red. The red is the only thing that is passed through. If we take a full spectrum light source that's white, all the colors, we put a magenta filter first. That's going to let through red and blue, and then a cyan filter is going to only allow the blue through, so you end up with just blue light. Generally, we don't put two filters together. You can do it, but generally you don't, just because they'll burn out faster. So that brings up, what is a gel? What is a color filter? Well, it's a kind of a plastic-like material, plastic film basically, that is tinted different colors. So it is consumable. They do burn out, which is why you have to replace color once in a while if your show is running for a long time. So these are the three manufacturers, the biggest manufacturers of theatrical color filters. Roscoe is the one that I use the most, but you can use any of them. And basically the way we identify the color is with the letter R for Roscoe and then a number. So R17, that's an amber or a flame color. G and then a number, L and then a number. I'm not as familiar with the Gam or Lee numbers because I don't use those brands of gel very often. But these three things here, these are swatch books that you can get, and it'll show you all the colors that they sell. And then you buy them in sheets or in rolls. You cut out the pieces you need, you put them in a frame like this, and then you slide that into the front of the light, and that'll color the light subtractively. Okay? So the second type of mixing is additive mixing. That's where you take 3 lights, or 2 lights, or however many lights of different colors, and you mix them together. You just shine them on something. And you can see how that works right here. If you take a red and blue, mix them together, then you'll get a magenta. If you take a green and a red light, you'll get a yellow color. So this is often how we mix colors on backdrops. We'll have red, blue, and green colors across the whole backdrop, and then we'll just mix them together to create whatever color it is we're trying to create, rather than having 8 different colors. If we want all those options, we will just mix the colors we need like this. We'll do additive mixing to get the colors that we want. And this applies, additive mixing applies to to all the lights we use, both subtractive and additive. We will subtractively color the individual lights, and then we will additively mix them together. So I'll have maybe amber lights from the front and blue lights from the front, and by changing the proportions of the two, I'll get different colors. So the amber is subtractively created in an individual light. The blue is subtractively created in an individual light, and then I additively mix them by shining them both on an actor or scenery or whatever it is. So what's one practical application of additive mixing? It's creating a vibrant white light. This is just an example. It's better, you can create a more vibrant, or it's not necessarily better, but you can create a more vibrant white light by additively mixing 2 very light tinted colors together. Why? Because our eyes are more sensitive to red, blue. They're sensitive to red, blue, and green, right? So they're more sensitive to color than to a mixture of all the colors. These colors are more specific. Their red and blue and green content is more specific than this full spectrum white light. So if I want to create a very vibrant white light, I'm actually going to use color, and I'm going to mix the colors together, and I'm going to get white by doing that. We often use pale colors in our front lights because we want to be able to see the actors, and we'll mention that again later. But this is just a practical application of additive mixing. It's just an example of how we use it. This light is subtractively colored, this light is subtractively colored, and they're additively mixed. Okay? Relative direction and color blending. This is fairly obvious, but if I take 2 lights and I place them completely apart from each other, like this, and shine them on the same person, this is what's going to happen. One side is going to be red, one side is going to be blue, obviously. There's no real color blending going on. But if I take those same 2 lights and I put them closer to each other, their relative direction is nearer each other, then I'm going to get much more color blending. I'm actually going to blend the colors together and create magenta. So the point of this is that the color of the lights influences where the lights go, and where the lights go influences the color. Because of this, because the direction, the relative direction, affects how the colors actually mix together. There are a lot of other subtleties about color that we just don't have time to talk about. So, but these are the most important things: subtractive mixing, additive mixing, understanding that basic color wheel, and this relative direction and color blending idea. So, at this point, we have completed our talk about what lighting design is. We now know what lighting design is. We had the basic definition, we talked about the 4 functions, and then we talked about the 4 things that we can control. Okay? So next we're going to talk about how the design is actually documented. Alright, we've talked about what lighting design is. Now let's talk about how we actually document the design, because we have to be able to communicate it to the people who are helping us and the other people who are involved in the show. So what I mean by documentation right now is the documentation that's used to communicate the arrangement of lights necessary to realize the design. So I'm not talking about the documentation that would be necessary to completely preserve or recreate a show. If I wanted to reproduce the lighting from a show that was already done, I would need more paperwork than the paperwork I'm going to talk about right now. This is just the paperwork we need going into the theater. This is what we need to be able to hang the lights the way that we need them to be hung for the show that we're doing. So the 3 major pieces of paperwork are the lighting plot, and that's a drawing that depicts exactly where every lighting instrument is to be placed relative to the stage and scenery. So it's a drawing that shows where all the lights go. The instrument schedule is a spreadsheet version of that, and it also contains additional information. So it's just a spreadsheet of all the lights we're using with all the information we need to know about every single one. A lighting section is a drawing that illustrates the heights of the lights relative to the stage and scenery. And this drawing is generally less important than the lighting plot. It might be optional. It's not as useful as the lighting plot, and we'll see why in a minute. Okay, so lighting plot. This is the view that you would see on a lighting plot. It's a plan view. It's a ground plan view. So we're looking straight down on the stage. The position, or first, we've already talked about lighting positions. So our lighting positions are shown here: front of house, upper front of house. This is a freestanding boom. These are our pipes over the stage. These are all our different lighting positions. We illustrate where a light is placed using a symbol. So each one of these symbols represents a particular type of light. And then we convey the important information about it using labels. So you can't see it real well on here, but there are labels in front of and behind and on top of the symbol that has all the information we need to know about that light. So that's what a lighting plot is. And you can see here that we're showing the position relative to the stage and the scenery. So we can see the stage. We can see where the boundaries of the stage are in this drawing. And we can also see where the scenery is. Now, what you're seeing here is the scenery from My Fair Lady. My Fair Lady has a lot of different scenes in it. Right now you're just seeing the Higgins study is what you're seeing in the background there. Now this is technically not a finished lighting plot because it's missing some things. It's missing a border. The drawing would actually have a border around it. It would have a title block with the name of the show and things like that. It would have a legend to tell you what each symbol meant, what kind of light each symbol represented. It might have different annotations. It would tell you the scale of the drawing. It would also illustrate things like sight lines. what the audience can see from their seats and what they can't. So that type of stuff would be included on a complete lighting plot. What I'm showing you here is pretty much just what kind of view you would see in a light plot, and how it works. It's symbols and labels, and you can see the different lighting positions from above. Okay, so this is our instrument schedule. It's for My Fair Lady, but basically it's the spreadsheet version. So an instrument schedule is sorted by the position. This is where the light is, front of house. The unit number is the order that it is on, that a particular light is on a pipe. So it's from stage left to stage right. If I say unit number 3, it's the third light from stage left. That's just a way of being able to communicate where a light is. I can tell someone, go fix light unit number 3 on the front of house, and they'll be able to find it. Other things, some kind of something that's meaningful to the designer, what the purpose is, the dimmer, the channel. We already talked about those. We need to know what dimmer it's plugged into. That's also the circuit number. That's also the DMX packet associated with it, but we call that dimmer. And channel is the channel to which it's assigned. So we have both of those things on this spreadsheet. What type of light it is: Source 4 Junior 36 degree. That's an ERS, an ellipsoidal reflector spotlight, 36 degree beam. And then the color, R04, Roscoe 04 is an amber color. Okay, so that's our spreadsheet version, and this is just an excerpt. It would show all the other lighting positions below this. Let's see, did we talk everything about that? Another thing about this is when we sort this spreadsheet differently, say we resorted it by channel, we sorted all this information by channel, then we would rename this. It wouldn't be called an instrument schedule, then it would be called a channel hookup. If we sorted it by dimmer, it would be called a dimmer hookup. If we sorted it by color, it'd be called a color schedule. By purpose, a purpose schedule or something like that. If we sort it by anything other than position and unit number, then it has a different name. Okay, a lighting section. This is the view you would see in a lighting section. You're looking at the stage from the side. So the point is that really what it's used for is to see sight lines and clearances. So again, this is not a finished drawing. If it were a finished drawing, you would see maybe an audience seat here with a symbol, and it would show what the audience can see with a line. Okay, the audience, this isn't the correct position, but if it were, the audience can see this light. The audience can't see this light because it's behind a curtain, whatever. This angle, looking at the stage from the side, is used to analyze those sight lines and make sure that the audience can't see lights that they're not supposed to, or things that they're not supposed to. It's also used for illustrating clearances. This is the My Fair Lady scenery, and the lights just clear it. The curtains just clear it. So we need this view. This view is very important for being able to check those sight lines and check those clearances, but it isn't always necessary to produce a finished drawing with title block and border and all that, because it's mostly it's for practical purposes. We don't necessarily always need it. So okay, those are our three main types of documentation. So we need those three things when we go into the theater to put the lighting together. That's how we know what to do, basically. Okay, so we know what lighting design is. We know the basic documentation we need and what it tells us. Last thing in this section is how do we actually make design decisions. This you might rephrase this by asking, how do we learn how to design, basically. We know what lighting design is, but how do you actually learn how to design? And these are the ways that you do that. First one, obviously knowledge gained through books, websites, manuals, mentors. So just reading things and talking to other people who already know it is a good way to learn how to design. So that's the first one. Second one, obviously you have to have some experience gained through practice. Every time you do a show, you get a better idea how you should go about things. So experience is crucial. Third one, testing in the lab. Your light lab, what you use as a light lab, might just be your head. Maybe you can visualize things in your head, in your mind, easily. So you might test out different ideas in your head. You might, so your mind, or you might do it with a computer. There are lots of different rendering programs and visualization programs and things. I've used them a little bit, but in my opinion, they're just really slow, and they just take too long to render things. So, but you can use computers to test out different things, or you can do practical testing. You can use real lights, real color filters. Maybe in a small setup, you can get some practice that way, and it's much faster than doing it in a computer, and it's more accurate than doing it in a computer because it is in real life. Or you can use some combination of all of those things, but the point is that you should do some sort of testing in a lab type situation where you're testing out your ideas to see if it's going to do what you want or what you think. And then the last one, so that's testing, and then the last one is by observation. If something doesn't look right, figure out why it doesn't look right and change it. You can't really rely on this method alone because it would take a lot of time. It would take a lot of time to try and do a whole show that way, but it helps later in the process, especially because you might have gone through all this work and then you just see one or two things that just doesn't look right, and if you figure out why that one thing doesn't look right, then you can just change it. So that's another important way that you should make some decisions. So that's how we make design decisions. That's how you learn how to design, in case you're wondering. So that concludes this section. We've talked about what lighting design is. We've talked about how we document it, the documentation we need going into the theater to be able to put the lighting together, and we've talked about how you actually learn how to design. So that's the end of this section.